Good afternoon, everyone. I'm Darrell Proctor of Power Magazine, and with me today are three power generation industry experts. We're going to discuss what happens when automation, advanced generation, and nuclear innovation converge. With me today are Tom Quinlan, Vice President and COO of the products business for Yokogawa Corporation of America. We're also joined by Risto Pauldenius, Vice President Americas for Wärtsilä North America. And also with us is Creighton Geppel, Executive Vice President and General Counsel for TerraPower. Each of these companies is a global player in the power sector, tackling reliability, sustainability, and scalability in today's complex energy landscape. And I'm going to immediately follow, since TerraPower was mentioned at the end of the last session, and start with Creighton. Could you give us an update on the Natrium project in Wyoming? I can, but I'm not sure everybody else can.
Yep, there we go. Okay. Yeah, thanks for that. The Natrium project, let me give a little bit of background on it first for those who are not familiar with it. We're working on a new reactor type, a sodium-cooled fast reactor that we're constructing in Kemmerer, Wyoming. And it's a 345 megawatt electric plant. In addition to the nuclear island, we also have an energy island, which will be thermal salt storage that we will use in order to store the heat from the nuclear reactor. And it will give us the ability to flex upwards to 500 megawatts electric capacity. We began construction in 2024, and I'm happy to give an update on all of the progress we've made in 2025, which I think is pretty exciting. And we'll hopefully go towards some of the comments in the last round. First on the regulatory side, we've made amazing progress in terms of moving forward on the regulatory front. We've got an industrial siting permit approved by the Wyoming Industrial Siting Council. So the first advanced reactor to get a set of state permits like that. So that was done in January. In early this year, we also got an approval from the NRC to allow us to begin non-nuclear construction as well at the site. Because the split that we have between the nuclear island and the energy island is really a big benefit for the Natrium deployment, because we can start on the non-nuclear construction a lot earlier, before we have regulatory approval to proceed with the nuclear construction, which is a big, big benefit for the Natrium technology. In addition to that, in July of this year, we heard from the Nuclear Regulatory Commission that they would expedite consideration of our construction permit application that we put on file with the NRC in early 2024. And now they have, they've indicated that we should be in a position in early 2026 to receive the full construction permit application approval, which will be about a year ahead of schedule for us, which is fantastic news as well. We have also successfully gone through all of the safety reviews in relation to the Natrium reactor. That was approved early in 2025. And just this month, we got confirmation that the NRC is issuing its environmental impact statement, which again is going to be favorable. So everything's on track for us to be way ahead of schedule on the regulatory side for the Natrium reactor. Let's turn next to procurement. In that space as well, we've placed all of our long lead procurements for major components for the Natrium reactor in the middle of this year. So that has also occurred. And on the financing side, because at an early stage, the thing that nuclear reactors do burn is money. On the financing side, we we're having great progress in that area as well. And in fact, in the middle of the summer, we announced another convertible note financing that raised $650 million from not only existing investors, but also from the investment arm of NVIDIA as well, N Ventures. So that's going well as well. And then on construction, which is a real proof of everything, we're making great progress there. We started construction, like I said, in 2024, and we're making good progress on a number of the non-nuclear pieces while we wait for the NRC approval, including a sodium test and fill facility, a training center, and we're ready to go for purposes of broader construction when that NRC license gets issued. So we anticipate being America's next commercial scale nuclear reactor that's going to be online. Thanks.
Okay, thanks for that, Creighton. I'm going to shift gears a little bit here and go to Tom. Where does Yokogawa see the future of power generation headed over the next 3 to 5 years, and what strategic steps is your company doing to support this expansion?
Thanks, Daryl. First off, I'd like to introduce Yokogawa. So the people who do not know who Yokogawa is, we are an industrial automation company that manufactures control and digital solutions, as well as measurement sensing solutions and R&D testing solutions. One of the things that mentioned by Michael earlier about the movement of data centers from power utilization, we actually believe that some of this effort started almost 20 years ago. Intel and the chip manufacturers started doing testing. They had a group put together called SPEC. They actually were doing testing from 10% to 100% of server utilization. That moved on to the Google and Meta and Amazons of the world looking at the power supply efficiencies. We all know 1% savings in power supply efficiency saves on heat coming out, and then the power usage that's needed. Then you move to the data converters. I think a lot of people don't understand that when the three-phase power goes into the data center, it then gets converted to 800 volts DC that's used by those servers. So again, all those efficiency efforts are being worked on, and those are areas that Yokogawa is involved in from the start, from an R&D test solution. And we fast forward to today, and you start looking at the suppliers, several of them in this room, from GE to Siemens to Mitsubishi. They're supplying turbines. Well, what do we need to have happen? We need to have reliability. We need to have efficient systems that deliver what they state they're going to deliver. And those are areas that need highly reliant instrumentation that several of us in the instrumentation world are providing today to be able to give that. And then I think the next step then becomes the new projects. People talk about how fast they need to go, the areas they need to work on, and we talked about workforce requirements. The EPCs are working on these projects. We're working with them to, as well as the end users, working with them on MIV development, right? A master instrument vendor, to be able to give them one source to be able to supply that instrumentation as a whole. That gives them a company that understands the process and can then deliver on time for what they're after, what they're looking for, and eliminates a lot of that procurement and engineering requirements they have up front.
Thanks for that, Tom. I'm going to go to Risto. So one of the things in the chaos, as I like to describe it, of the current U.S. energy landscape, one of the technologies that seems to be actually prospering is energy storage. Can you talk a little bit about Wärtsilä and what they're doing in energy storage? I know a lot in Europe, and maybe touch a little bit on, or a lot, on what's going on in the U.S.
Perfect, thanks, Daryl. Yeah, Risto is from Wärtsilä, a Finnish company, and we're in the marine industry and energy sector. About 19,000 people working in a global corporation, about 6 billion turnover annually. So on energy storage or energy side, we have a reciprocating engines, RICE, as it was mentioned on Epri's presentation. So we have about 80 gigawatts globally installed, and here in US, about 6 gigawatts of RICE plants installed. And then on the energy storage side, I think we have about 7 gigawatts energy storage systems globally, and about 4 gigawatts here in US. On an average, about 2.5, 2.7 hour systems. So you can calculate the gigawatt hours from that. We've seen a lot of growth, of course, on a thermal side here for us. US been a little bit tougher market now for the energy storage. Globally, talking about the energy storage, some of the Asian countries like Australia has been installing a lot energy storage systems, and for example, there we've been very successful. But if I can come back to US, certainly for our company, we started with the co-ops, munis, providing 100 megawatt power plants, moved to utility scale, bringing up to 200 megawatt plants, and now we're very much just like our gas turbine friends and other engine manufacturers, seeing tremendous growth in data center markets, and now we're discussing about 2, 4, 5, 600 megawatts plants to support those data centers. Typically off-grid solutions.
I'm going to stay with you because we talked earlier about supply chain issues, and I know, I believe you guys manufacture a lot of your own equipment. So, are you, as impacted by some of the supply chain issues as perhaps some other groups are?
I think just like in a previous panel, somebody mentioned, or an EPRI's presentation, that since the COVID, times have been supply chain challenges have been pretty tough for the energy industry. For us, we manufacture on energy, engine power plant side two product lines, if I call them that, 10 megawatt and 20 megawatt engines. So we still see pretty good supply situation with the smaller units that we produce, and delivery time still being about 12 months or so for those units. On the larger units, which is a little bit the preferred size for us, particularly here in US, the delivery times are a little bit longer, but we are considering building more capacity for us, and which of course needs to make sure that we have also the supply chain ramped up for that, just I think like everybody else today.
Thanks for that. I'm going to go back to Creighton. The Natrium project and advanced nuclear technology, I mean, that's really what TerraPower is all about. How do you see your company? Is there any kind of evolution that you see with your company and the nuclear technologies that you're working on over the next however many, 5, 10, 20 years?
Yeah, great question. We actually have two different advanced reactors that we're working on. One is the Natrium reactor, and that's farther along, and it's a sodium cooled fast reactor. We have another project, the molten chloride fast reactor, that actually uses uranium chloride salts as the fuel, and it has a lot of promise. It is a little farther off in terms of technology readiness, but it has potentially great applications in other areas, for example, in maritime applications, for example, for decarbonization. So we're looking at multiple different technologies in terms of continuing to be able to supply the needs that are going to emerge. I think a couple of other things, just to focus again on the Natrium technology, which really is our flagship technology, which we're most focused on. First, the fact that we have a nuclear island paired with this energy storage is a great attribute for purposes of the markets, because it really creates a lot more flexibility in terms of the Natrium reactor to be able to ramp to supply variable demand. So that's a fantastic attribute of it. I think the other thing that separation between the energy storage and the Natrium nuclear island creates is the opportunity to move a lot faster when it comes to construction for Natrium reactors. We're expecting that the construction time period for the nuclear island piece could be as low as 36 months. subsequent commercial reactors. The other thing that's important and a big differentiator between our technology and existing light water reactor technology is that our reactors are at or near atmospheric pressure, as opposed to systems that are under high pressure, which has huge benefits from the standpoint of constructability and a lot less requirements in terms of concrete and steel that are necessary for other types of current light water reactor technologies. So we see huge benefits ultimately with some of the innovations that we've been working on in this space that will pay off when we've completed construction for the first Natrium unit.
Thank you. Tom, I want to come back to you. I know Yokogawa works with so many different power generators and different companies, helping them with their technologies and, enabling delivery of reliable energy while managing risk and maintaining operational efficiency, as you mentioned earlier. What are some of the things that you're seeing that customers are asking you guys to deliver for them, and what are the major issues that they're talking with Yokogawa about?
Thanks, Daryl. So we were very fortunate to join an executive forum a couple months ago with several executives across multiple industries, and the majority of our discussion revolved around this part, whether it's natural gas powered plants, data centers, those, and the movement of water, gas, and electrical molecules, right, and the storage of those as well. And it turns out, so many of these things fall even into the water wastewater market and other parts of other industries. And the biggest question mark that comes up is unplanned outages. As Michael mentioned earlier about the workforce, the maintenance workforce is getting older, and it's moving into retirement. And how do you make that movement for the future? We don't have a guy who can walk by a pump and say, that thing's going to fail in 2 weeks. We don't have that available to us anymore. So really predictive maintenance becomes a major factor going forward. The utilization of IoT, AI, sensing technologies from vibration to corrosion to steam traps to multiple others become the movement of the future. We're starting to see some companies adopt that and really make a movement to use that as part of their planned outages for the future. And I think that's one big area. The second area, and I think everyone hears this, and if they haven't, they've been behind a closed door in a closet for the last 3 years, is cybersecurity. Cybersecurity is a big aspect that's going to continue to be looked at. I mean, it doesn't matter whether your website's down for 2 hours or the fear that your plant's going to be down. Those are things that everyone's looking at, and those are things that we're working on, as well as some of our other colleagues are working on to help in that control system as well as instrumentation side.
I want to follow up on that because we've had sessions on cybersecurity previously at Experience Power, and one of the takeaways has been that people will come to us and they'll say, well, the only people in my company that care about that are the folks who work in IT. And we just shove everything to them and let them deal with that. I want to ask each of you, with your respective experience, how are your groups dealing with the cybersecurity question? And Creighton, I'll start with you.
Yeah, it's an important piece that we have to focus on, and it's not just our IT group's problem. I mean, it cascades through so many of the different things that we do. I mean, first on the regulatory side, to get an NRC license, we have to have very good systems in place in order to ensure that we have cybersecurity for our plant. So that's one area of focus. Another is with our customers too. I mean, the expectation is clear in the contracts that we enter into with customers and the ones that are, under development, that we're going to have those issues very much in the forefront of what we're focused on. And the other, the other piece is really, when we look at the procurement side too, for purposes of our Natrium plant, because we have a whole bunch of different components that have to come together in one full plant, and we're only going to be as good as the weakest link in that whole process. So it's a big focus for us. It's a good question.
Risto?
Yeah, I would put this in two categories. One is, of course, for us when we deliver power plants and sometimes quite often maintain and even operate the plants. How do we make sure that that power plant is secured and from all the cyber threats? And that's one thing. Or when we do updates on the control system. For example, we have here in Houston, Texas, we have our Houston Expertise Center, which is NERC CIP certified, which then we can connect to the customer's site for remote monitoring, but also operations in the future. So that's one thing that, the customer side for us. And then, of course, the other side is for us, our own company's operation. How do we make sure that we are secure? And we just run through an exercise internally and wanted to see that what would happen in the organization and how does the organization react when you have a cybersecurity incident, and that was kind of hairy practice to do that. What happens in an organization when you get a cybersecurity threat and then there's a blackmailing coming and more information coming piece by piece, and how do you do that? How do you inform potentially then the customers that this is going on in your company, and does it affect the customers or not? So I would highly recommend training exercise around that. It's a bit hairy, and that raises very quickly the importance of the cybersecurity, the top management. I can promise you that.
Tom?
I have to agree with both of them because it's about basically what we've gone through as a whole as well. Doing distributive control systems for companies, of course, that's a major factor. And adding that cybersecurity on top of that control system is very, very impactful and very important. But as he mentioned, we also have the ability to connect and work on those from a service standpoint. So it becomes highly important that those things are in place to be successful. But I will tell you, having attended WEFTEC a couple weeks ago in Chicago for the water wastewater, I never imagined how important it was for water wastewater as well, and how many conversations we had just in that industry discussing cybersecurity and the concerns that are going on. So it's across all parts of our business.
Yeah, thanks for that. I want to ask the audience, how many of you have had the training courses with the gentleman whose t-shirt reads human error? Come on, show of hands, come on. Well, we have a few. I think some of you are not responding correctly, but anyway, so Tom, I want to go back to you. Again, you guys work with companies globally, and so obviously cybersecurity important. And let's talk a little bit about how you're helping those companies navigate the energy transition and upgrade existing assets, and maybe some of the protocols that Yokogawa has instituted to help with that.
So I'm going to be the first one to move that rock and see if there's a snake under it. Someone asked me yesterday how tariffs were affecting me. Prior to April 2nd, I don't know that I knew the word. For the last 6 months, it is an everyday part of my life, and I think that we'd be kidding ourselves if we're not looking at that and seeing how it's affecting us. And earlier, the industry people were talking about the costs and how do you handle those costs, right? And those costs are escalating daily. So one of the big things we've looked at, and my concern right now is from a North American standpoint, is how do we grow the local manufacturing here, right? And how do we make that more so we have something local, can get it there quickly, and that's what we're doing in our Atlanta facility. I know that some of our other companies in the instrumentation side are doing the same. And the other thing is we talk about workforce, it's training. I've talked to companies in the power industry, oil and gas, you name it. The new people they're bringing on, they're trying to train them online. It's not the same as touching the equipment and being there, especially when you're talking about putting new maintenance personnel in those facilities. So we're actually, with our new facility, building a new state-of-the-art training facility. I know that some of our competitors from Emerson and Anderson Hauser have done the same. These are things that are going to benefit the industry going down the line. I think the last thing would be, you talk about people and you talk about workforce and how you help them make sure their assets are performing at a high level. I think the energy transition is going to need that. Asset performance management software is going to be a vital part of that. And we see that in the investment that's being made across all industries. We're looking at ways in which you can give advanced analytics, simple dashboards, and digital tools to really improve the performance of all your assets. And I think that's an important factor that we'll continue to see grow over the next 3 to 5 years.
Thanks for that. Risto, how does your company view the U.S. market right now versus how it may view what you're able to do in Europe?
I think we see the tremendous growth, particularly in U.S. for our company globally looking at it. We reach, I would say, every country in the world with our sales force. But and it's been before the boom in U.S. It was maybe Indonesia or Pakistan and different places where we sold a lot of power plants, gigawatts. But now it's certainly been last 2.5 years here in U.S. And of course, now the data center boom is there. So if there's no power, there's no data center, there are no exceptions. So that's really driving our focus right now and making sure that we have a capacity also for this tremendous growth.
You touched earlier, and I know on both energy storage and like the RICE engine part of your business, do you guys see a particular growth path based on geography worldwide for either or both of those technologies?
I think what is interesting, and interesting to learn myself more on hybrid solution. Right now, we get a lot of requests on-site power, 24/7 power plants, wind turbines, or engines for that. But what the future will be for that, and how do we manage that in the whole data center campus, if you wish, with also maybe hybrid solutions, being energy storage, longer 2-hour, 4-hour energy storage system, but potentially then integrating also renewables in that. And how do we manage? We have a EMS, energy management system, in-house built that can optimize and operate all those systems to a millisecond level to the managing the frequencies. So I think there's something to look at that, and maybe in the future then talking about energy efficiency more. I don't think we see too much of that discussion. It's just the speed to power who can provide the thermal assets on the ground the fastest is today the winner. But I think as we progress further, we'll see hybrid solutions and also then other solutions that how do we actually make the whole data center ecosystem more efficient.
Yeah, thank you. Creighton, you touched earlier on how with Natrium and the technology that your group is developing, requiring the alignment across government, utilities, private industry. How is TerraPower structuring its partnerships in the U.S. and elsewhere, if that's applicable, to bring the Natrium technology online, and what priorities are you guys considering when negotiating these agreements?
Okay, let's start with the elsewhere piece because in addition to the U.S., we had an announcement this week about our submission to the Office of Nuclear Regulation in the UK of a generic design assessment. And so what that is basically a shadow process to follow on the NRC licensing review that is occurring here in the US. So we're moving ahead with additional markets outside the US as well for purposes of Natrium deployment. And the UK is the first one where we're pursuing that. And we've gotten good support working with the UK government and also with private industry in the UK. I guess turning to, broader partnerships, here in the U.S., I mean, the first one that I wanted to highlight is just with the U.S. government, because TerraPower back in 2020, 2021, competed for and was awarded the Advanced Reactor Demonstration Program award, which was a 50-50 cost share grant with the U.S. government for purposes of creating the first natrium demonstration reactor. And that's been a great partnership together with the U.S. government. I think on the regulatory side, I think the current administration has done a number of things to remove regulatory hurdles that have been helpful. As I was talking about the NRC, the NRC construction permit application. I'm a little bit worried in some instances, though, that some of the zealousness that folks have for trying to strip out regulatory issues may go too far. I mean, with the Nuclear Regulatory Commission, it's really viewed as the gold standard around the world, and I think there are some, I'd say, less mature companies in the nuclear space who want to tear everything apart, and I think that would be a big mistake, frankly, because the safety reviews, for example, that the Nuclear Regulatory Commission do are essential to be able to earn the public's trust in nuclear energy. And it's also going to be essential for us to move at scale when we go internationally, because we want to leverage what the NRC has approved here in the US. And the credibility of that approval is extremely important. So I think that that partnership with the U.S. is really important. The partnership too with suppliers and the supply chain is going to be critical for us as we're moving from the first of a kind development in Kemmerer, Wyoming, to try and scale for subsequent nuclear reactors, commercial natrium nuclear reactors, because there's a lot of investment to be done in the nuclear supply chain, because we haven't done as many nuclear reactors in this country for a long time. So that's going to be an important set of partnerships. And then also on the construction and technology side, that's going to be key too with our EPC contractor. We're working with Bechtel on Kemmerer Unit 1. On the fuel fabrication side, working with GNF and also with GE Hitachi as well on some of the technology development, and with many, many others. And then also on the customer side too, because as we're looking at deploying a number of natrium reactors following the Kemmerer Unit 1 that we're building in Wyoming, there's going to have to be some appropriate risk sharing and connection with those next natrium units that we're going to have to work on together to try and ensure that we manage those risks and also properly allocate them. So there's a whole host of different partnerships across the spectrum that we're working through.
One thing I want to ask all of you is just get your opinion on the thinking that it's going to require more private investment, that the private sector is going to have to step up in a bigger way to get energy projects across the finish line if we don't have government support for certain segments of energy. And feel free to weigh in however you wish on that question.
Well, I think they mentioned it earlier. It's certainly, if the Medas of the world and those people, they're going to have that money to move that forward. But I think the real question mark, we had this conversation at that executive forum. There was a couple data centers who'd bought their own gas turbine. Well, they didn't realize they got to get access to gas. They got to get access to all these other things. And suddenly, oh, we got a turbine, but we're still 2-3 years out from being able to actually get power out of that thing. So I think there's a lot of items that we have to get past there to make that next step, especially with the movement. And, talking to people at Southern Power, they're getting calls every week. but then they've got to look and see where they can run transmission lines, where they're going to put this, and then are they going to get the support of the people in that area?
Yeah, I think there's a lot of private capital available for the thermal generation right now. So I'm not sure if much of a support is needed on that side. But a little bit going back to new technologies and innovation. I think that if we go back to 20 years, we didn't have a solar panels really. We didn't have a wind and all these new technologies. They needed to some government support to actually start scaling up and developing the technologies. And I think we still need that. Being fuel cells or solid state batteries or small nuclear reactors, I think there is still need for that in that new innovation space. So I'm fully supporting on that side, and when they get up and running, and of course then the subsidies and support should come to an end. But at the early stages, I still think that's needed.
Great.
Yeah, this is the perfect question because I was on a panel yesterday for the data center session yesterday on financing, and I think there's huge interest, in connection with this from private investment, and it's interesting because I reflect on it in terms of my own career at TerraPower. I've been there about 12 years, and when I first started there was no plan to do deployment here in the U.S. We were looking abroad to do our deployment because there wasn't this huge growth opportunity that existed. The market has changed fundamentally in terms of the opportunities that are out there. And I think investors are very much waking up to that. And they're not going to be doing that alone either, because I think when we look at some of the tools that are available from the U.S. government in order to support this, those are pretty substantial too. You've got the ITC and the PTC tax credits that are available that will help to bring online additional capacity. In addition to that, you've got the DOE Loan Programs Office, which has indicated that they have over $200 billion available between now and September 2028 in order to help support new energy projects, and at very favorable terms. We're talking 30 years interest-only loans, basically, and at an 80% debt ratio. So there's substantial support coming from the government as well. There has been some speculation too that maybe there could be cost overrun insurance or other things like that. I don't think that's going to get funded, actually. But those other tools that I mentioned that the government's providing, the DOE LPO support plus the tax credits, those are huge, and they're enablers for private investment.
So I want to go down the row here before we wrap up and ensure that you're each able to get out whatever talking points we may not have yet discussed. So Tom, I'll start with you. Anything that you would like to tell the audience in terms of questions they might have about the power generation industry?
I think that right now, as far as the instrumentation and industrial automation side of the business is moving fast, and it's continuing to move faster. And I think that you'll see continuous improvements in that area as we go forward, and I think this growth will bring that. I've lived through the telecom boom and was actually in that part of the business in early 2000, and I saw how it moved. I'm very excited about what this opportunity brings, and I think that we will see quite an advancement from an instrumentation sensing side of the business to help support this growth from on the power industry side.
Yeah, maybe from my side, looking at the tremendous growth in renewables in last 10 years, what we've seen is the more need for flexible power generation and flexible local power generation. I think this super grids that was tried in Europe that will connect everybody to everywhere, and through that balance somehow, and that didn't really work out, and I'm not really a strong believer that will happen anywhere. So therefore I think we need a local flexible capacity, which is truly flexible. And going a little bit, I'm a power plant engineer, and what little I remember of that, but truly how we define the flexibility is how quickly you can actually start up your assets, how quickly you can ramp up and down, 1% per second or whatever it is, and then how long you can need to stay online until you can go offline, and how quickly you can ramp up back again. And then what is the minimum load for your assets when there's these load swings and generation swings that need to happen, and how many times per day or month you can cycle your assets. We have one a power plant here in US which in the last 8 weeks started 3,300 times. They have 18 units, and if you calculate then divided by weeks and days, that's 3.5 starts per individual engine in a single day. So this is kind of like the operational flexibility we see that is a lot needed thanks to the renewables, but also then in the future with the data centers. You're talking about large language models, data centers, and when the spikes are high, of course you have super caps and UPS is taking some of that smoothing out, but you still need the thermal assets to be able to respond to these very big load demands. So I think that is something that all technologies need to develop further on.
Yeah, thanks for that, Creighton.
Yeah, I was just going to say my day job actually is to be the lead lawyer for TerraPower, and so even though I talk a lot about improvements in technology and the like, what I tell my team all the time, and share this with the business teams as well, is we need to not only innovate on the technology side, but in terms of the approach that we take in terms of structuring different arrangements, contracting, and the like. We need to be equally as innovative in that space in this new environment, and I think we're doing that. I think there's great opportunities for how we manage our different partnerships and relationships to allocate risk and bring about the change that we obviously need to make happen to satisfy this exciting new opportunity.
Okay, thank you.